start this problem. This problem is centrifugal pump. This centrifugal pump drives this one. Is the Q. Is also height. Height is given. This is the water height. Water height is the 16 meter, and diameter of the pipe. Also diameter of the pipe is 150 millimeter, and also long. L equal to is the 22 meter long, and overall efficiency. Overall is the 75%. Calculate the power needed to drive pump. Take the friction coefficient. Also F is given. Right. We have to calculate the power needed. We know the pump efficiency. We know Q is rho G H. This one is the total height and divided by power. We have to calculate the power. So P and efficiency. Right. And then we don't know we know the Q. Okay, we know Q, we know rho, and G we know, and efficiency, but we don't know what will be the HT, or that means the total height. Right, total height we can, in the Bernoulli equation, the HT or HT total height equal to static height plus and P square divided by rho G and plus B square 2G plus SF. Right, all of this, because pressure is not given there, so this is no need for us. So we have put this static height is given 16 meter. Right, but velocity we are not looking here, but we have to find out another. The Q we know, right, and AV, this means area, and velocity. Area, diameter we know, we can find easily. The V equal to Q equal is the 0.055 divided by and by 4, and D square actually is the 0.150 square. Then V velocity, and easily we'll get the velocity. We are getting the velocity is the velocity 3.1 on meter per second. Just put over here 3.11 square divided by 2G square divided by 2G. Also another, this means frictional height. Frictional height is equal to F equal to F into L divided by D plus V square divided by 2G. Just F coefficient we know 0.05, and L also long. How many long? 22, and diameter 0.15, and velocity 3.11 square divided by 2G. Just after calculating coefficient, we will get the 3.62 meter. Just 3.62 put, and then we'll get the actually the HT total. Total. Okay, HT will be HT. What will be HT? Total height will be 20.11 meter. This is the total height. Right. Then we'll put here this formula. Here we'll put this value. Actually the P or Q is a 0.055 meter cube per second, and then rho we know 1000 into G is 9.81, and A's total height is the 20.11, and also efficiency is the 0.75. After calculating power, we'll get the actually 19 point, wait, after calculating we get the value is 19.4 HP. This is the power, this is the HP, horsepower. Or we can write the kilowatt. We can write the kilowatt. Kilowatt is the 14.47 kilowatt, right? Kilowatt. This is the answer. I hope you have got this. Okay, thank you. Here one thing, remember, you can remember this one thing, and that is, I'm telling you, this is the confusion point. This is the confusion point. This is the confusion point. This one with AST, because maybe you can think this height and this height. No, this height is the only water to height. It's the static height. It's not the total height. But we have to calculate the total height by using Bernoulli equation, by continuity equation. We have to calculate, and then we'll get the total height and put over the equation. Then we'll get. Don't do mistake and don't put in the equation in this 16. This is the very remembering thing, and you have to so much careful about that. This 16 is not the total height.